Hey coders, and welcome to episode 5 of our Pandas playlist. In today's episode, we're going to be learning appending and merging. Now what I mean by that is that we're going to learn how to take two separate data frames and combine them together both horizontally as well as vertically. Alright, so for this video I have chosen 5 distinct methods which we'll be looking at in the code. And they are insert, append, concat, merge, and join. Now, just to be honest with you, you probably won't be using all 5 of these methods in your daily Pandas coding. For instance, you'll probably be using concat and merge way more often than you'll be using append and join. However, I'm going to be showcasing all of these methods just in case you are, say, reviewing someone else's code and you happen to see someone else use append or join, at least you know what they are doing or what they are intending to do with these methods. All right, without any further ado, let's jump on in and over to the code and look at these methods at work. We have returned once again to our nice looking Jupyter lab. And the first thing I'm going to do is run this top cell to import pandas as PD. And I'm also going to be importing the random Python module because we'll be using it in a demonstration in one of these later code blocks. Next, I'm going to be reading in the same CSV which we have been using throughout the course of this playlist, and then assigning that to the student's data frame. Again, all of this data should look very familiar because we have been using this data in all of the prior episodes. Next, though, I'm going to be importing a new CSV and then converting that into a data frame, and I'm going to be calling that data frame the college's data frame. Now, this data frame is a lot smaller than the first data frame. We only have 8 rows. However, each of these rows looks like it corresponds to a university or a college that has an ID, a name, and then also a location. Now the cool thing about this data frame is that it actually relates to our first data frame. As you can see, each of these colleges has an ID, and then each of these students has a corresponding college ID that relates to one of these universities. Cool, so we're going to see how to combine these two data frames in a later code block, but let's move on first off to something a little bit more simple. Alright, so let's say that you wanted to add a column or columns to a data frame, and this is actually a very common practice when coding with pandas. Now there are many ways of doing this, however I believe the quickest and also the most convenient way of adding a new column to your data frame is through assignment. So if we take a look down here, this is, let's say that we wanted to add a new column to our student's data frame. So to do that, we would access a new column, see right here, date of exam, as if it was an existing column, right? This column right here, date of exam, this doesn't actually exist in our data frame right here. We don't see data, or we don't see date of exam listed as a column name. However, we're going to access it as if it did exist, and then we're going to assign it using the equal sign a value. Now this value could be either a scalar, a list, or an existing series. So let's go through them one by one. Alright, so if we are assigning a new series to a scalar, then that will give every value of that column the same value, which is the scalar that you have assigned to it. So if I were to run this cell right here, we can see that now this new column has been added to our existing data frame, and every single value of that column is the scalar that you assigned it to, right? 2, 22, 22, and that is what we assigned it to right here. Awesome, so that is how to assign a scalar, but let's say that we wanted to assign a list. Well, we can also do that. So in this second demonstration, this second example, we can see that now we are trying to add a new column called experiment group, and then we are assigning that to a list. Now whenever you assign a column or a series to a list, the list has to be the same length as the existing data frame. So this is 1,000 rows. So what I'm going to do is actually make a list comprehension right here. I'm going to loop through the range of the rows, right? So we know that the shape argument, right, or the shape attribute will give us both the number of columns and rows. So we're going to access the number of rows. We're going to loop through that number of rows. And then what we're going to do each time we loop is take a random index of this tuple right here. So we have group A, group B, and group C. And we're just going to take a random element of this tuple. Cool, so if I now run this cell, we can see that a new column has been added, experiment group, just as we named it right here. And we have all the values, say, equal to group C, group B, or group A. But all of this looks pretty random which group each of these students landed into. Awesome, so that, again, we can assign new fields, new columns to a list. However, if we already have a pre-existing series, we can just assign that series to the new series, right? So I'm actually, in this example, I'm going to take our existing series experiment group right here, which we just created, and then assign that now to a new column called experiment group copy. Again, it's not really a glamorous example, but this is just to prove that, again, assigning a series to a new column can work. So if I were to run this, now we see that we have generated a new column called experiment group copy that is the exact same as this column right here, experiment group. Cool. So we can also assign multiple columns at once. So again, just as if you wanted to access two columns by passing in a list into our bracket notation, right? We can actually assign a column for country of residence and state of residence. Again, these don't exist yet in our data frame, equal to a list that has to be the same length as the number of columns, right? And the elements of this list can be either, again, a scalar, a list, or an existing series. So right now I'm just going to give them scalars. And if I run this cell, then we can see that now two new columns have been created, one for country of residence, one for state of residence, and they have been assigned the values of USA for country of residence and California for state of residence. Awesome. So that is how to assign, or that is how to create new columns through assignment. Now there is actually a method for creating new columns, and that is the insert method. So again, we can also use the insert method to define where we want our columns positionally, right? So this is actually a little bit more functionality than just the assignment. So now, if we were to use this method insert, we would first declare where or which data frame we want to insert into, and then this first argument would be which column position we wanted to insert into, knowing that this is 0 indexed. So in this case, student ID would be index 0, gender would be 1, race would be 2. So we would want to then now insert this new column called high school into index 3 right here. And then we would give it a value, whatever value we wanted to give. Again, this could either be a scalar, a list, or an existing series. So if I were to run this cell now, we can see that we now have this column high school inserted into the third position of our data frame. Now we get another cool perk by using the insert method, and that is that insert will not overwrite a column that has the same name that you're trying to insert, or the same name that you're trying to insert. So if I were to try to run this exact same method again, there's already a column called high school, and I'm trying to add another column called high school in the same position, no less. Then it's going to give me an error, and the error is cannot insert high school already exists. Now, if you want to overwrite this, then you would say allow duplicates equal to true. And then that basically what that would do is that it would just create a duplicate column now. Both of the names are high school. So I'm going to run this, and there we go. Now we have a duplicate column called high school. I'm not sure, again, why you would ever want to do that, but just in case you wanted this to work without error, then you would now have a duplicate column called high school. Awesome, so let's keep moving on. So that's how to add a column to a data frame. Now, adding a row to the data frame through assignment is basically the same logic. So as we learned in a prior episode, if you wanted to access a row, you would either use .loc or .iloc. However, if we want to now add a new row through assignment, we cannot use .iloc anymore. We have to use .loc. So that's what I'm going to do. Now I'm going to try to add a new row or append a new row to our colleges data frame. So if you recall, this is what our colleges data frame looks like. I'm going to try to add a new row that has the named index of 8. Cool, so the values of that is going to be a list. Now again, we can also assign it a scalar. That's totally fine. That means every single value of that row will have the same value, or every single cell of that row will have the same value. But I'm going to assign it a list, and so this is going to be the ID, the name, and the location. Cool, so if I run this, then there we go. It looks like we have now appended a new row to our existing data frame with these corresponding data points right here. Cool, so that is how to add rows and columns through assignment. However, most of the time you probably won't be adding individual rows, right? If you're trying to add new data to an existing data frame, and you're trying to add, say, new rows to that data frame, then most often you'll have like a big bulk of new rows that you're trying to append to your original data frame. And then you'll want to use a more advanced method. So the first one that we're going to look at is .append. Now again, just as a disclaimer, this method was deprecated as of Pandas version 1.4. So it's not suggested that you use it. However, it is used still in the wild, right? So you'll want to at least be familiar with it and at least recognize what it does, just in case you're reviewing anyone else's code. Like, this still works, however, again, Pandas has deprecated it. Cool, so let's look at this method by looking at the colleges data frame. So again, let's say that we wanted to add in multiple new colleges, right? We have a whole entire new data frame called more colleges. And again, I only added 4 rows, but let's say you had even more than this. This would be a new data frame. Now, the columns are the exact same, right? We have ID, we have name, we have location. So if we wanted to append this data frame to our colleges data frame, which means that we wanted to stack them, right? We wanted to stack them vertically, then we would use the append method, just like this. Cool, so let me run this. I'm not going to, again, spend too much time on this just because, again, this method is deprecated. But look, here we go. Our colleges data frame, we would access the data frame that we wanted to append to. We would say .append, and then we would append that other data frame. So this was our original data frame right here. And then all we did was basically stacked on, at the bottom, this new data frame. Now, something you might be noticing is that our indexes, they're not unique anymore, right? This was index 0, and it looks like when we appended our new data frame, it basically just took the same exact index. So now, this is kind of like a not good practice. Like, this is a kind of a bad practice to have the indexes that are not unique. So if you wanted to reset these indexes, all that you would need to do is just use an optional argument called ignore index and set that equal to true. And if I were to run this, then there we go. So after appending these two data frames, then it reset the index. So now the index runs from 0 through 12, and we don't have duplicate index names. Awesome. So again, that's append. However, and again, you might see this in the wild, again, if you're reviewing anyone else's code. However, how I would suggest that you append data frames vertically is by using the method concat. So using Pandas concat method is a lot more versatile, as it can combine series or data frames both vertically and horizontally. Cool, so let's take a look at that. So if we wanted to achieve the same exact result as this append method, all that we would do is use now the concat method. except for now this method is on the pandas parent class. So you would say pd.concat, and then in a list of all of the different data frames that you want to concatenate together, you would pass that list into the first argument position of this method. So if I were to run this, then there we go. We get the same exact result as we would have gotten using append. Cool. So again, and if we wanted to reset this index right here, all that we would need to do is use that same optional argument and just set that equal to true. Cool, and then we would get, again, that reset index from 0 to 12. Let me get rid of that for now so I can show you this axis optional argument. So if I were to say axis equals 0, this is the default. This will append 2 data frames vertically. But the cool thing about concat is that it has the ability to concatenate 2 data frames horizontally now. And the way to do that is to switch this 0 to a 1. And that signifies that now we are basically concatenating on the columns. So if I were to run this now, look at that. So now this data frame that we had right here, the more colleges data frame, has been added horizontally, right? This basically was just smushed together horizontally. Now again, we get duplicate column names, but again, if we wanted to, we could, that's something we could change easily. But look how easy it is to use this method concat to either lump them together vertically versus lumping them together horizontally. All it takes is just changing this parameter right here, axis, to either 0 or 1. And the way I remember this is that the 1 kind of looks like a column, right? I mean, the symbol right here for 1 is straight up and down. It kind of looks like a column. So this means that the axis is going to be combining the columns together, right? Cool. All right, so that is concatenating. Now the next one is merging. Cool, so this merging we're going to spend a little bit of time on because it is very important and very useful. So merging is for, this merge function mimics the relational database style joins. So I'm not going to be going too much into the theory of like SQL joins. That is a topic for another video. But if you're already familiar with that, then in order to replicate that same behavior in Pandas, you'll use the merge function. All right, so you can specify inner, outer, left, right, and cross joins on 2 related columns or indexes from different data frames. And as you can see, we have a lot of different optional arguments shown right here. All right, so if I just were to run this cell right here and say pd.merge the student's data frame and the college's data frame and not specify anything else, then what Pandas is going to do is it's going to try to look for a column or a common column name from these 2 data frames. So if I were to go up here, look at the student's data frame, then we have these column names right here. And if I were to look at the college's data frame, then we have ID, name, and location. Unfortunately, none of these column names match. So again, if I were to run, let's see, pd.merge right here, then it's going to give me an error, and the error is going to be no columns to perform a merge on. So it gives us some merge options that we can use, which we'll now look at. All right, so just to showcase though that this does work, I'm going to create a common column. I'm just going to quickly say rename, and again, we haven't learned this method yet, but I'm just going to quickly write it in. I'm going to now rename the ID column in our college's data frame to college ID. I believe that's what it was called up here. Yep, college ID, cool. So now that I am renaming the ID column in college's DF to college ID, then now both of these data frames have a common column called college ID that it's going to perform an inner join on. If I run this now, then there we go. Now we have a merged data frame that has been combined on the college ID, right? So now this college ID right here has been combined, and now we're getting the names of the colleges and the location of the colleges that correspond to each of those college IDs. Awesome. Before I continue, I'm actually going to reset our students data frame just so that we can clear a little bit of space. I have like some of these columns that I don't really want anymore. So I'm just going to reset our students data frame. Cool. And if I now run this again, there we go. Now it's a little bit more clean. Cool. So now again, it merged on college ID. It looked at every single one of these college IDs, and then it looked then at the college's data frame to get the corresponding ID, and then merged these two fields alongside that college ID in the same row. Awesome. So let's keep moving on. So let's say again that you didn't want to, if you didn't have a column name that was similar between the two data frames, and you didn't want to always have to rename your column names in order to merge on them, then what could you do? Well, Pandas has these really cool left on and right on optional arguments. So basically what these are doing is, what is the column name that you want to join your left data frame? So whatever data frame you specify in the first optional or the first argument. And what is the column name that you want to join with your right data frame, which is again the second data frame that you specify. So knowing that students data frame has the college ID name and college's data frame has just a generic ID name that we want to join on, we can use, say, left on is going to be equal to college ID. And then right on is going to be just equal to ID. And now that we're telling Pandas that, hey, we want to join the left data frame on college ID with the right data frame on ID, then Pandas now knows what to join together. Cool, and now again we can see that all of these indeed have been joined. All of these definitely match, and we still get our 1,000 rows. Awesome, so Pandas also allows you to, the merge function allows you to join on an index. So if I were to say left index is equal to true and right index is equal to true as well, now what this is going to do is it's going to grab just the indexes of the two data frames and merge them together. Now as you can see, this only returned 9 rows, right? 0 through 8. And that is because, again, this second data frame only has 9 rows and we are doing an inner join. And again, the college ID and the ID, they don't match up at all because, again, we're joining now on the indexes. So let's say that we wanted to get now a left join so that we could get the original 1,000 rows. All we would need to do is just specify how is equal to left. If we run this, then there we go. Now we have our original 1,000 rows, but again, it's joining on the index. So some of these indexes right here, like 995, that doesn't correspond to an index in our college's data frame, right? So all we're going to get now is just NANs for these columns, ID, name, and location. And let's just look at the head, the first 30 rows, just to bring this home a little harder. All right, so again, looks like we have just the first 8 or 9 rows of our college's data frame, and then everything after that is an NAN because we are doing a left join. Let's look at one more of these optional arguments, and that is indicator. So if I specify indicator equals true, again, by default it's false, but if I say indicator equals true, what this is going to do is it's actually going to create for us an additional column called underscore merge. If we wanted to, we could change the name of this column to whatever we wanted to, and we would do that by just saying equals and then whatever string we wanted it named. So if I did this, then now the column name is called data lives in, but regardless of whatever it is, the values in this column are used to indicate where the data is from in this row. So this row says both, which means that data in this row originated from both the student's data frame and the college's data frame. And we can verify that because, again, look, all of this data right here is from the student's data frame, and then these last 3 rows right here are definitely from the college's data frame, right? We joined these 2 together. However, if we scroll down a bit, we can now see left only, and that is because all the data from this row is exclusively from the left data frame, right? We didn't get any information from the right data frame, from the college's data frame, because all that returned was NaNs, right? So all of the data in this row is from the left data frame. And then again, there's a value for right only as well, and that would be the case if you had all the data from the right data frame and not any data came from the left data frame. Cool, so that is pd.merge. Again, it's a very super important method to learn, so I would recommend that you practice it a whole lot in joining. And again, if you need some refreshing on inner joins and SQL joins and relational database joins, then I would definitely want to again refresh your understanding on that, because this is definitely the same behavior as a relational database style join. Cool. I guess one more thing that I forgot to mention was this on optional argument. You would only use this one if you had multiple columns between these 2 data frames that had similar names. So if you had more than one column that had a similar name between the 2, then you could specify which column you're talking about that has that similar name, and then you would just specify that here. But again, most often I'll just use left on and right on. All right, so let's do one more to wrap up this now getting pretty long episode, and that is the .join method. Again, this is less common than merge. However, Pandas does support it, so it's important to know. I almost never use the join method. I always use .merge, but again, in case you are reviewing anyone else's code and they happen to use the join method, at least you know how it works now. Cool, so this method is less versatile than merge, but it does exist. So what join does is that it looks actually only at the indexes, right? So if we wanted to join together student's data frame with college's data frame, it's going to look at the student's data frame index and join that with the college's data frame index. And as we've already seen, when it does that, then all it's doing is looking at the indexes and joining them together, which means that for records such as this one, which has an index name of 996, we're getting NaNs, right? Because this record right here with index 996 does not live in the college's data frame. Cool, so there are some other optional arguments that you have. Let's use one of them now. So let's say that we wanted to let's just use the on. Let's look at the on optional argument. So what this does is instead you can actually specify for the student's data frame that you don't want to look at the index, you want to look at a column. You're still going to be looking at the index for the college's data frame, but if you wanted to specify a column for the student's data frame or whatever you're using, whatever data frame you're using for the join method, then you can say on equal to, and then I'm just going to actually give it college ID as that. Now again, because college's df has just a range for its indexes, let me do something really quick. I'll say set index, and I'm going to set the index as ID. Cool, so now what this does is that because we set the index of our college's data frame to the column ID, then now we can actually join on those two columns, right, or there's 2 indexes with the college ID and the ID, and get the data frame that the joined data frame that we were expecting. Cool, and then you can also use L suffix and right suffix. This is mostly just if you wanted to, if you had like a common column and you wanted to know which column came from the left side and the right side, you could add like a suffix to those column names. I'm going to let you play around with that, but that's going to be it for this episode. Again, it was kind of long, but all of the information in this episode is extremely important, so I would just really try to emphasize that you practice it a lot and get very familiar with it, because this is kind of like where the power of Pandas comes into play with all of these mergings and concatenations. Again, the two most important methods of this video is going to be pd.merge and pd.concat, so I would really focus on those two in your practicing. But again, it is important, I suppose, to know if this ever does come up in the wild, at least you'll know what .append and .join do. Alright guys, I hope you learned a lot from this episode, and I hope you liked it. If you did, don't forget to hit that like and subscribe button, and I'll see you in the very next episode.